Lesson 4.3 takes us into, officially, it's multiplying and dividing rational expressions. We're actually going to kind of start before that, and we're just going to start with simplifying rational expressions. Everything we do through the rest of the chapter. Today, we officially are multiplying and dividing. In the next lesson, we start adding and subtracting rational expressions, and then eventually we're solving equations with rational expressions. So everything we are doing from here on out has rational expressions in it. So has the fraction expressions that has the variables in the numerator and denominator. Okay. So reminder, rational expression is the quotient of two polynomials, so two pieces divided. The domain is going to be all real numbers except for any time the denominator can equal 0. And so that's one of the things you're going to be asked to do is you're going to be asked to find restrictions on the variable. And when we do that, that'll be checking to see where our denominator equals 0. And then a little side comment I have here is that expressions with a plus or minus sign. We often talk about those terms being what we call married. And with that idea in mind, that when you have terms that are married, so added and subtracted together, they cannot be canceled. We can cancel factors, but we can't cancel individual terms. So for instance, if I use this example right here, there's a minus 4 and a minus 4. It's tempting to want to do that, but we can't. Okay? We can't cancel a minus 4 and minus 4 just because they're both being subtracted here. Okay, so it's all going to be about factoring. We're going to review lots and lots of factoring and practice lots and lots of factoring, and then look at canceling those factors. Okay, so we're going to start here, and we're going to start by simplifying each expression, which, as I said, it's going to involve lots of factoring. And again, here's the no. Can we just say x squared and x squared canceled? And that's the huge no. Okay, because those x squareds are added and subtracted to other terms. So, we're going to talk factoring. Okay, what do you guys remember? X squared minus 4. How do we factor that? What?
X plus 2i.
No, we're not going to have any i's in our factoring. Does this go into two parentheses? It does. X squared minus 4 is what I would call difference of squares. What's the square root of x squared, or what's x squared break into? X times x. What about 4? The square root of 4 is 2. So it's going to be 2 and 2. And how do we multiply to get minus 4? You're going to have a positive 2 and a minus 2. Okay, so difference of squares, that's one of those factoring pieces you have to remember. What about the denominator? X squared plus 3x minus 10. Hopefully you recognize it as one of our traditional factoring setups, where it's going to break into two parentheses. We know x squared breaks into what? X times x. And then what do we need in the way of numbers? Two numbers that multiply to be negative 10 and add to be 3. Okay, yeah. I'm just going to say it's a combination of 2 and 5 somehow or another. And since it multiplies to be negative, you need a positive and a negative. Since it adds to be positive 3, we want the 5, the larger number, to be positive, the smaller number to be negative. Okay, so your first step in everything you're doing today is factoring. Get everything factored out. Now, what do you notice here? What do we have? On top and bottom, both involve a factor of x minus 2. So the rule is 1x minus 2 on top can cancel with 1x minus 2 on bottom. Okay? Now, in terms of the other ones, we have an x plus 2 left on top. We have an x plus 5 left on bottom. Again, that x on top is connected to the 2. The x on bottom is connected to the 5. So we're not canceling those. So at this point, you're at x plus 2 over x plus 5. And that is your simplified version. As I said, it's factor, 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 and then cancel. Now, the other piece, most of the problems we're doing, I think all the problems we're doing in the notes involve asking us to find restrictions. Not all homework questions will ask you to find restrictions. You'll just have to watch the directions. But restrictions. This is a fraction. A fraction can't exist if your denominator equals 0. So when we start talking about restrictions, restrictions occur anywhere the denominator equals 0. So what we're going to do in order to find our restrictions is we're going to set our denominator equal to 0. Now, when I start talking about setting my denominator equal to 0, we can go back to the original denominator if you want. So the x squared plus 3x minus 10. Although if I set x squared plus 3x minus 10 equal to 0, what am I going to have to turn around and do? I'm going to have to turn around and factor it again. So my recommendation at that point is use the factored form. The factored form before you canceled anything. So any factor that was ever in the denominator is what we want to set equal to 0. So I'm going to suggest we use that form right there in both pieces. So I'm going to set x minus 2 equal to 0, and I'm going to set x plus 5 equal to 0. So any factor that was ever in the denominator, we're going to set equal to 0. And we're going to solve it. If it's x minus 2, I'm going to add 2. I'm going to get x equals 2. If it's x plus 5, I'm going to subtract 5. I'm going to get x equals negative 5. Those two values right there are what we're going to call restrictions on the variable. They actually are the fact that x cannot equal 2 and x cannot equal negative 5. Those are the two values of x that make this problem not possible. Okay? So, with that in mind, set each factor of your denominator equal to 0. Solve them. Even if it was a canceled factor, you still want to use it and solve it. And then those two pieces are my restrictions. Okay? So this fraction exists. X can be anything except 2 and negative 5. Okay? Questions there? No? Okay. Let's do some more practice then. Okay? I'm going to show you quite a variety of factoring. Okay? I'm trying to get you a little bit of each of the factoring skill sets so we can kind of, review our factoring. It's all factoring we've already seen before, but again, we got to review it. So, okay, let's look at B. X squared plus 2x plus 1 over x cubed minus 2x squared minus 3x. And again, it's all about factoring. What about the numerator? X squared plus 2x plus 1. What do you recognize?
GCF. Oh, the top one.
On the top. Hold the GCF thought. What about the numerator though? X squared plus 2x plus 1, does it look like it could probably go into 2 parentheses? Okay, when you have that x squared, x, and then a number term, I'm not going to guarantee it, but it's probably going to go into 2 parentheses. X squared breaks into x and x. I need 2 numbers that multiply to be 1. That's my only option for multiplying to be 1. 1 times 1. And if it multiplies to be a positive 1 and adds to be a positive 2, what do we need in the way of signs? Plus 1, yes? Okay. What about that denominator? Now what do we need to talk about?
The GCF.
Now let's talk about GCF. This one is not ready to go into 2 parentheses, is it? When you've got x cubed, x squared, next term, you're not ready to go into two parentheses. So what do all three terms have they can divide by? X. There's an x. So we're going to factor that x out front. Make sure you write it in there. X cubed divided by x takes me to x squared minus 2x squared. Divide away an x is 2x minus 3x divided by x leaves me with a minus 3. Okay. Am I done factoring? Probably not. And here's what I'm going to say, probably not more than anything. Does anything cancel yet? No. I'm not going to say it can't happen, but it's going to be really unusual if nothing cancels. Usually there's something that cancels. So my top stays the same. X plus 1 times x plus 1. What about that denominator? You've got an x out front. X squared minus 2x minus 3. What are you going to guess? Probably goes into two parentheses, yes? Let's try it. X squared, of course, is going to be x times x. What do we have happening here? Two numbers that multiply to be 3. What's my only options for multiplying to be 3? 1 and 3. Now, if it multiplies to be negative 3, one of each, a positive and a negative. If it adds to be negative 2, how are we going to make this work? Okay. Plus 1 minus 3. Okay. Now, is there any canceling that can happen? Yeah. What do you see? X plus 1. Now, what you've got to make sure you realize, it's a 1-for-1 deal, not a 2-for-1 deal. 1x plus 1 on bottom cancels with 1x plus 1 on top. Okay? So 1x plus 1 on bottom cancels with 1x plus 1 on top. In order to cancel that other x plus 1 on top, you'd have to have another x plus 1 on bottom. Okay? So it is a 1-for-1 deal there. Anything else cancel? No, nothing else cancels. So everything else is just going to carry across into my answer. So on top, I still have an x plus 1. On bottom, I have a factor of x, don't forget about it, and a factor of x minus 3. Okay? We don't usually multiply anything back together. We usually leave it in factored form. And don't forget to do your restrictions. Okay, how do we find our restrictions on the variable? Set your denominators equal to 0. Okay, as I said earlier, use your factored form before you canceled anything out. Okay, so I wouldn't go back to the original. I wouldn't go back to where you only had GCF. I would use your factored form before you canceled anything out. So what's that mean? I'm going to be setting equal to 0. I'm going to be setting a factor of x equal to 0. I'm going to be setting a factor of x plus 1 equal to 0 and a factor of x minus 3 equal to 0. Because all of those were in the denominator at some point, even if they weren't. So what do we know? The first one, x cannot equal 0. X plus 1, subtract the 1 over. Yeah, that works. And add the 3 over. So we're going to have x, I have it, I'll get it, cannot equal negative 1. And x cannot equal 3. That's right on top. I hope you're using my stuff by now.
Thank you.
You're welcome. Okay, so we've got 3 restrictions here. Okay? All of that to say, first one we had 2 restrictions. Here we had 3 restrictions. You might only have 1 restriction. You could have 5 restrictions. Okay? It just kind of depends as the problems. As we get into our multiplying and dividing, you'll see more restrictions on the variable, but any factors in the denominator, set equal to 0. Okay? Okay. And I've got one more here. I'd be tempted to skip it, but there's another factoring skill we've got to practice here. Okay, I'm trying to, have you noticed, we've done difference of squares, we've done basic product and sum, we've talked GCF. What about this one? Should we start with the denominator? Or you guys got any ideas on the numerator? What about that numerator? There's 4 terms. Is there GCF in all 4 terms? No, there's no GCF in all 4 terms. Do you remember a factoring skill to use when there are 4 terms? Okay, it's what I call factoring by grouping. So yeah, cutting it in half. Okay, so when you have 4 terms, can't guarantee it's always going to work, but it's what you need to check. Think of terms of cutting it in half. So I'm going to cut it in half after the second term. Look at just the first 2 terms. What kind of GCF do just the first 2 terms have? Yeah, my first 2 terms both have an x squared, so we're going to factor out an x squared. If you factor out x squared, x cubed divided by x squared leaves us with x plus 4x squared divided by x squared leaves us with 4. Now repeat the process on the second half. So what about this minus x minus 4? What do they have in common? Okay. Yeah, negative 1. If all else fails, there's always a 1 in common, yes? In this case, since its lead term is negative, we're going to factor it out as a negative 1. And you could just write a negative there. I'm going to write mine as negative 1, though. Negative x divided by negative 1 becomes positive x. Negative 4 divided by negative 1 becomes positive 4. Okay, now I'll come back and grab the denominator in a moment, but guys, there's good news here. This factoring by grouping is working because my parentheses match. Okay, so when you go to the next step, it goes into 2 parentheses now. 1 parenthesis are your GCFs. What were my GCFs? I had a GCF of x squared and minus 1. So 1 parenthesis is x squared minus 1. The other parenthesis is your GCF of the matching parentheses. I had matching parentheses, yes? This is why they have to match. My matching parentheses represent my other parenthesis of x plus 4. Okay, so that's where we're at on the numerator right now. Now, before I go any farther, we need to go back and grab the denominator, yes? X squared plus 3x minus 4. I don't know about you guys, but to me it looks like it probably just factors into 2 parentheses. X squared breaks into x and x. Multiplying to be negative 4, adding to be 3. Well, multiplying to be 4 is 1 and 4 or 2 and 2. But in this scenario, we're going to have to use 1 and 4. If it multiplies to be negative, one of those is negative. If it adds to be positive, larger number positive, smaller number negative. And I'm just going to carry this over here as x minus 1 times x plus 4. Now, before we proceed, is all of my factoring done? Is there more factoring that can be done? And there is. Sometimes you'd be done at this point. Sometimes you're not done at this point. In this case, we're not done. There's a little more factoring that can be done. What about this x squared minus 1? X squared minus 1 is a lot like factoring x squared minus 4. It's the difference of squares. Okay, so we have to do one last step of factoring here. X squared minus 1 goes into two parentheses. X squared, of course, is x times x. The square root of 1 is 1. So 1 times 1. If it multiplies to be a negative, what do we need? A plus and a minus sign. Okay, so that's the x squared minus 1. X plus 4, carry it along. Denominator was x minus 1 and x plus 4, carry it along. Okay? Now, with all that said and done, is there some canceling that can happen? Yeah. Okay. Definitely some canceling that can happen. Thank you. What do you guys see? Okay. 1x minus 1 on bottom cancels with 1x minus 1 on top. And 1x plus 4 on top cancels with 1x plus 4 on bottom. What remains? X plus 1. Officially what? X plus 1 over what? If everybody cancels on bottom, what is technically left? Not 0. 1. Now, is Savas going to like this answer right here? No. What are they going to want? If everything cancels on the bottom, it's just x plus 1 over 1. They're just going to want x plus 1. Okay? Now, if the 1 was in the numerator, it would matter then. But since it's in the denominator, you can just drop it off and you just have x plus 1. Okay? Okay, what about restrictions? Restrictions on the variable, you're going to set your denominator equal to 0. What factor denominator do we want to use? Really, you can use any of them, right? Your fully factored denominator before you cancel anything. X minus 1 equals 0 and x plus 4 equals 0. Solve each of those. If it's x minus 1, you're going to add 1. X cannot equal 1. If it's x plus 4, we're going to subtract 4. And x cannot equal negative 4. Okay? So I will say when I get down to the multiplication section, I usually start listing those just as numbers with commas between them. It's not that you have to say x cannot equal every single time. Okay? Okay, guys. Factoring review. Is the factoring coming back to us? That's the big thing this lesson. You have to be able to factor. You got your factoring skills? All good? Then it shouldn't be too bad. Okay, but we've got to get those factoring skills under control. Okay, so this officially was just simplifying a rational expression. Now we're going to multiply. But here's the deal. Multiply, we're not doing anything new. Okay, multiplying, you're doing the same thing. It's going to be factor, 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 and then it's going to be cancel. The only difference is you have two fractions that you're canceling with it. Okay, it's still the same idea. Absolutely not am I going to recommend that you multiply before you factor? Okay, that is the one big no-no. We're not going to start multiplying this. I know the problem is a multiplication problem, but that's going to get real ugly real quick. So your job is to factor and get those common factors canceled. So here we go. What are your thoughts about x squared minus 16? We've already done this twice today. This is 2 parentheses, difference of squares, right? X squared minus 16, so x squared is x and x. What's the square root of 16? 4. And if it multiplies to be negative 16, then what do we need? A positive and a negative. Okay? So difference of squares. I need you guys recognizing that one. What about x minus 9? Okay, yeah. The best you could do for x minus 9 is a GCF, but there's not even that other than 1. So x minus 9, don't drop it. Don't lose it. It just carries along, though. Okay? X squared plus x minus 90. Well, no guarantee it's going to work till we figure it out, but does that look like 2 parentheses possibly? Yeah. And that's what you're going to want to assume most of the time, that it's going to factor into 2 parentheses. X squared, x times x, multiplying to be negative 90, and adding to be 1. So we want 2 numbers that multiply to be 90. They're only 1 apart from each other. Yeah, 9 times 10 is 90, yes? Okay. So 9 times 10. If it multiplies to be negative, I need one of them being negative. If it adds to be positive 1, larger number positive, smaller number negative. And repeat the factoring one more time. X squared plus 14x plus 40. X squared is x times x. Multiplying to be 40, adding to be 14. Okay. 10 times 4. If it multiplies to be positive and adds to be positive, they're both positives. And guys, if you guys get stuck on some of these, because I saw some of your faces on the 91, or even the 40, start making lists. Okay, if you get stuck, you can't find the pair, go through your list. Like 40 is 1 and 40, 2 and 20, 3 doesn't work, 4 times 10, 5 times 8. Make those lists until you find something. Okay? Okay. Once that you've got everybody factored, what cancels? What factors do you guys want to cancel? Okay. 1x plus 10 on top cancels with 1x plus 10 on bottom. What else cancels?
X plus 4.
1x plus 4 on top cancels with 1x plus 4 on bottom. And 1x minus 9 on top cancels with 1x minus 9 on bottom. Okay? So, note, the only thing we've changed up here, you've got 2 fractions. It's always, when you're canceling, it's always a top and a bottom. Okay, it's never canceling 2 tops or 2 bottoms. But you can cancel on the same fraction, or you can cancel on opposite fractions. Okay? Either way. What remains as my answer? Yeah. I mean, you could say x minus 4 over 1. But since there's nothing left on bottom, it's gonna end up being x minus 4. Okay. And they did ask for restrictions on these 2. I'm trying to get you guys well practiced in the area of restrictions. Just like above, how are we going to find our restrictions? Setting your denominator equal to 0. My recommendation, your most factored form. Okay? So in terms of denominators, we had an x minus 9 in the denominator. We had an x plus 4 in the denominator and an x plus 10 in the denominator. So what are my restrictions? X cannot equal what? Add the 9 over, subtract the 4 over, subtract the 10 over. X cannot equal 9, negative 4, and negative 10. Okay? So by all means, yes, list them with commas, that's fine. Just remember it's what X cannot equal. Okay? Are we getting the hang of this? Don't look too excited. Okay. Well, let's keep practicing a little bit here. X plus 3 over 4x times x squared over 4x plus 12. Okay, x plus 3. Thoughts on factoring x plus 3? Okay, x plus 3 is x plus 3. Thoughts on 4x? It's just one term, isn't it? Now, I will give you a hint. 4x is 4x, but I also want you to keep in mind that 4x is also 4 times x, if you would. Just hold that thought, okay? Okay, my next numerator, x squared. Well, again, x squared is just one term, isn't it? But here's going to be my hint. X squared is what times what? It's x times x. Think of it that way, if you will. And what about 4x plus 12? Might we have to do a teeny bit of factoring here? What about 4x and 12?
GCF.
GCF of 4. So if you factor out a 4, 4x divided by 4 is x, plus 12 divided by 4 is 3. Okay? So really, the only true factoring we had there was the GCF on 4x plus 12. Now, what cancels? Okay, so the obvious 1x plus 3 on top cancels with 1x plus 3 on bottom. And I gave you a hint already, but there's one other thing that's going to cancel, and what is that? The x, right? Okay, so 1x on top will cancel with 1x on bottom. Now, and we can do that because those are factors. They are pieces that are being multiplied together. That's why we can do that. Now, is this other x on top going to cancel? No. This 4 on bottom, does it cancel? No, because it would have to have a 4 on top to cancel. Can a 4 on bottom and a 4 on bottom cancel? They cannot. Okay, so with this in mind, what remains for our answer? On top there is a what? Well, just on top in general is an x. On bottom, what are my pieces that remain? A 4 from the first fraction and a 4 from the second fraction.
So we don't like leave it two separate.
Leave it as two separate fractions. No, we're going to put it together as one fraction. I mean, technically, if you want, you could think of this as, at this point, we have 1 over 4 times x over 4, but we're going to multiply those together. Okay, so if you'd rather think this way, you can. When we multiply together into one fraction, this becomes what? X over 16. So whichever way you think to get there, final answer needs to become x over 16. Fair enough? My brain automatically just puts them together as one fraction. If you'd rather think 2 at first, that works too. Okay. And guess what I'm going to say? Restrictions on the variable. Okay. Restrictions on the variable. Anything that was ever in the denominator has to be set equal to 0, yes? And we could think of this a couple different ways. This first piece, it was 4x or it was 4 times x. I'm just going to put it as 4x here. Okay. Our other piece, I could leave off the 4, and what I need to talk about is the x plus 3. Thank you. Okay. On the 4x, you could drop off the 4, or you can make it 4x. On the x plus 3, again, we could put the 4 there, but here's the deal. If I talk about 4, does 4 equal 0? No, there's no variable there, is it? So that's why I don't usually talk about the numbers. I mean, that one just ends up not meaning anything. I just talk about the pieces that have the x's in with them. And so in terms of x, if it's 4x equals 0, well, what happens? You divide by 4. 0 divided by 4 is 0. So you have a 0 there. If it's x plus 3, subtract the 3, and you have a negative 3. So x cannot equal 0 or negative 3 in this scenario. Okay? Okay. Let's try C. We go till 15, right? Yeah. Okay, let's try C. I'm going to make you work. Now, first of all, this is a fraction times a non-fraction. What do we know about that piece that's not a fraction? We're supposed to be multiplying fractions here. How do we make it a fraction? Put it over 1, yes? So officially, now do I have fraction times fraction? Yes. Okay. Well, let's work on the factoring. We've got a lot to do here. What about x cubed minus 4x? What do you know about x cubed minus 4x? What? There's a GCF, yes? So let's begin by factoring out GCF of x. You factor out GCF of x, what remains? X squared minus 4. Okay. Now, what about your denominator? Six x squared minus 13x minus 5. Is there a GCF? No. If it's going to factor, we need to talk slip and slide. Can that pop up in this lesson? It can. Okay. So I'm going to come over here in the middle because we're not going to try and slip and slide that right there. I'm going to see if I can make it work right here. 6x squared minus 13x minus 5. So this is product of AC or slip and slide. Do you remember how to do this? Take the A value, the 6, and slide it over, yes? So now it's x squared minus 13x minus
30.
5 times 6 is 30. Okay, does that look like something that could factor? I hope so. Yes, it does. So let's factor this. X squared is x and x, multiplying to be negative 30 and adding to be negative 13. Huh? But does negative 3 and negative 10 give me negative 30?
Negative 15 plus 2.
Okay, this is the tricky one, isn't it? My gut wanted to go for 3 and 10 also. But with the signs, can we get 3 and 10 to work? No. And we've seen several like that today, right? Where it's been the number and 10. Unfortunately, you're going to have to go with 15 and 2 here. Negative 15 plus 2 gives me negative 13, and negative 15 times 2 gives me negative 30. Now, this is slip and slide, so what do we have to remember? Okay, we multiplied the 6 over. Now we have to divide the 6 out. Now, before you move those 6's out front, reduce those fractions to make this happen. What do we know about 15 over 6? Divide them both by 3, and that is 5 halves. What do you know about 2 over 6? 1/3. Now, move those denominators back out front, and we end up with 2x minus 5 and 3x plus 1. Okay? So, you have to reduce your fractions before you move those denominators back out front. Now, let's see. So 2x minus 5 times 3x plus 1 goes where? 2x minus 5 times 3x plus 1, barring I made no mistakes. Okay. What about this next piece? What about 2x squared minus, 2x cubed minus 3x squared minus 5x? Okay, first thing we need to acknowledge is there is a GCF. So I'm going to factor this GCF out front. Dividing an x out means each exponent reduces 1. So 2x squared minus 3x minus 5 all over 1. Okay. Am I done with all my factoring here? No, we're not. We're going to go for a round 2. Now, as we go for this round 2, x times x squared minus 4. Was that done? No. X stays out front as a GCF, but what about x squared minus 4? I need you guys to recognize that's the difference of squares, yes? X squared is x times x. What about 4? The square root of 4 is 2, and it's a plus minus. Okay. Denominator. 2x minus 5 times 3x plus 1. We already did our slip and slide there, so that just carries down. Okay, what about this second fraction? It has the x out front. What about that trinomial in the parentheses there? If it's going to factor, it's going to be slip and slide. And is there a high possibility it's going to factor? There is. So, let's bring it over to the side here. The 2x squared minus 3x minus 5 And let's slip and slide it. I'm going to slide the 2 over. So x squared minus 3x. 5 times 2 is minus 10. And what do we need to happen here? X squared is x times x. What multiplies to be negative 10 and adds to be negative 3.
Two.
5 times 2, and it's going to be negative 5 plus 2. And don't forget, what can we not forget here? We multiplied a 2 in, so now we're going to divide a 2 out. In this case, 5 halves doesn't reduce, so the 2 can go over here to become 2x minus 5. And over here, 2 divided by 2 is 1. Okay, so were we able to slip and slide again? We sure were. So we're going to fill that in over here. There was already the x out front, don't lose it. And we've got the 2x minus 5 and the x plus 1. And it's all over 1. Okay, guys. It was a lot of factoring, but it's just now about canceling. What cancels? 2x minus 5, 1 2x minus 5 on top, cancels with 1 2x minus 5 on bottom. What else? Unless we've made a mistake, nothing else cancels, does it? I don't feel like we've made a mistake. Nope, my answer has all those pieces in it. Okay. Reagan, I don't like the look you're giving me.
I just feel like
There's a lot of factoring.
unnecessary.
A lot of factoring, not enough canceling. I get it. Okay, as I put the answer together, what do we have in the front of each piece? X and an X, yes? What's the best way to write X times X? X squared. So for my answer, I'm going to have X squared times X plus 2 times X minus 2 times X plus 1 all over 3x plus 1. Will there be times where not much cancels? Yes, there's going to be times where practically everything cancels. There's going to be times where not much cancels and we're kind of annoyed that we just did all of that factoring and not a lot canceled. I get it. Okay. Okay, last piece of this problem is restrictions. Now, remember, anything that was ever in the denominator. What were my pieces in the denominator? Two x minus 5 was in the denominator, and 3x plus 1 was in the denominator, right? So, add 5, divide by 2, and I'm going to list that as 5 halves. Subtract 1, divide by 3. I'm going to list that as negative 1/3. So x cannot equal 5 halves or negative 1/3. Okay. I'm going to stop there. Tomorrow, we'll have one multiplication problem to review, get your brains together. Okay? And then we will talk about dividing on the backside and what all that means. Okay? 4.1 and 4.2, if they're not done, get them done. 4.3, could you start looking at? You can. It's not due tomorrow, but really the only thing we haven't talked about in 4.3 is divide. So